Hey guys, this is section 1, day 2 of solving one-step inequalities. And last time, you learned about problems that looked like this. 3x is greater than negative 27, or 2/3 x is less than minus 6. So those are problems that we looked at. Hey, but what if you see a problem that looks like this? Minus 3x is greater than minus 27. Hey, is that problem solved the same way as this? Well, let's take a look. Let's use a example here. Let me erase some of these. Okay, so let's get started here. If we had an example like this one, minus 3x is less than 9, how would we solve that? Well, if we divide each side by negative 3, we then can cancel out those negative 3's and bring down x, and we know 9 divided by negative 3 is negative 3. Okay, but when you divide each side by a negative number in inequalities, you need to switch around the inequality. So instead of facing that direction like it is right now, you have to turn it the opposite way. Now, why is it like that? Okay, so let's say we had the inequality 5 is greater than negative 3. Now, we know that 5 is greater than negative 3. That's a true statement. But let's see what happens when you multiply each side by a negative number. Okay, so 5 times negative 2 is greater than minus 3 times negative 2. Okay, well, 5 times negative 2 is negative 10. And negative 3 times negative 2 is 6. Well, oops, negative 10 is not greater than 6. 6 is actually greater than negative 10, so you'll notice that the inequality flips around. So when you multiply or divide by a negative number on both sides, you have to switch the sign. Okay, and that's what we're learning about today. Okay, so let's try a few examples that go with this. Okay, so let's look at this guy first. We have minus 8x is greater than 72. We know that we have to undo multiplication with division. So those negative 8's cancel, and you have x. And what's 72 divided by negative 8? Well, that is negative 9. But remember, when you multiply or divide each side by a negative number, we have to flip our inequality. So instead of greater than, we will have less than. So note that we flipped the sign. Okay, we flipped the sign. Okay, very important to remember that. Let's try another one. Okay, on this one, we have 7x is greater than negative 42. Okay, but we have to undo multiplication with division on both sides, and we're dividing by 7. Well, since we're dividing by a positive number, do we need to flip the inequality? Well, no, we don't need to do that. So if we cancel those 7's out, bring down our x, and we know that negative 42 divided by 7 would give us negative 6, and we can leave our inequality as it is. Now, just because you have a negative somewhere in your inequality doesn't mean you have to flip it. It's only when you multiply or divide each side by a negative that you flip. Okay, so be aware of that. Okay, so our rule that we've learned, we're going to write it down, caution. Okay, we're going to flip the inequality. Flip the inequality when you multiply or divide each side by a negative. Okay, so we're going to flip the inequality when you multiply or divide each side by a negative. Okay, so remember that rule. Make sure you have that written down. Very important for this unit. Okay, let's try this one now. Well, we have to undo this division right here. And how are we going to do that? We need to do that with multiplication. So let's multiply each side by -5. Okay, so those -5's cancel out. So we have x down here, and we know -5 times -3 would give us a positive 15. But since we multiplied each side by a negative, what do we need to do? Well, we need to flip around our inequality. So instead of having it face less than, we would have it turn to be greater than. Okay, but remember what we learned in the last note section, that we need to have x out front. And remember, the inequality is facing 15, so it needs to remain facing 15. So there's your final inequality. Okay, so this is an important concept. Make sure you have these 3 examples written down, and make sure you have the rule written down. We'll try a few more on the next page. Before we do any examples, I got a quick joke for you. How do crazy people go through the forest? Think about it. Think about it. They take the psychopath. You like it. All right, let's try a few examples. Some of these are going to use our rule that we learned, and some of them aren't. Okay, so number 1, we know we have to undo multiplication with division, and we're going to divide each side by 2. Well, we're dividing by a positive number, so we know that the inequality is going to stay facing the same direction, and we end up getting x is greater than or equal to 3. So that one we don't have to do anything to the inequality. Let's look at number 2. Okay, this time we have to undo division, and we have to undo division with multiplication. So what should we multiply each side by? Well, we need to multiply by -5. And since we're multiplying by a negative number, we need to flip our inequality the other direction. So those -5's cancel. And we're going to flip our inequality the other direction. And then 1 times -5 would give us -5. Okay, so we're not learning anything new today. We just are using a new rule. And this one, we need to undo this subtraction with addition. So we need to add 3 on both sides. And since we're not multiplying or dividing by a negative on both sides, we can keep the inequality going in the same direction, and we get t is greater than 8. Okay, let's try one more real quick. And we want to solve for p. How do we undo addition? Well, we undo it with subtraction on both sides, so we'll subtract 1. 4 minus 1 is 3. And since we're subtracting on both sides, we know that we're not flipping the inequality, so it can stay the way that it is. And last step, we know that we need to have the variable out front. And since the inequality is facing the p, it needs to remain facing the p. And we get p is greater than or equal to 3. Okay, I would like you to try these 2 by yourself, and then I will come around and check them. Okay, remember what our rule is and make sure you apply it to either one of these if you need to. See ya.